Welcome back. My name is Kevin Otieno and this is Form 4 Mathematics. The topic for today is loci. Now today, the types of loci we look at are constant radius locus and constant distance from a fixed line locus. Constant radius locus is also known as constant distance from a fixed point. Well, we will use this question to guide us. So it reads, the line PQ is 8 centimeters long and L is its midpoint. Then part A, draw the locus of point R above line PQ such that the area of triangle PQR is 12 square centimeters. B, if R is equidistant from P and Q, draw the locus of a point S such that PS is equal to 3.5 centimeters. C, shade the region enclosed by the locus of R, S and line RL inside the triangle PQR such that PS is greater than 3.5 centimeters and PR is less than or equal to RQ. So here we'll be tasked with identifying these types of loci from this question. So that is the next thing we will do. So let's begin with A. Draw the locus of point R above line PQ such that the area of triangle PQR is 12 square centimeters. So first of all, I want us to get this. We have triangle PQR, P, Q, and R must be somewhere at the top there. So that we have triangle PQR, and we are told that this triangle has an area of 12 square centimeters. So this information here will help us in getting the height of the triangle, and we'll see the importance of that height. So the base of the triangle, which is PQ, we already told is 8 centimeters. So we're going to have area of the triangle, which is obtained as a half times the base, which is 8, times the height. That should give us the area, which is 12 square centimeters. So if we work out this, we'll realize that H will be 3 centimeters. So the significance of this height H is that we'll be able to tell the locus of point R such that the distance between line PQ and the locus of R is always constant. So the locus of R should be somewhere here, so that that distance H is constant throughout. So that was the essence of getting the height of the triangle. So from here, we've just identified that the kind of locus we're looking at here is constant distance from a fixed line. So we have the fixed line PQ and we have a constant distance H, which happens to be the height of the triangle. Now remember, point R can be anywhere on this locus right up here. So if we have R at that particular point, we still have triangle PQR and the height is still H. Even if we have R at this particular point, right there, we still have triangle PQR. So this is the locus of R. So next, I will be tasked with constructing the locus of point R. So we are going to take a pair of compasses. So we put the pair of compasses at point P, so one end at point P, and ensure first of all that the radius of the pair of compass is 3 centimeters. So once you've measured that and place the end at point P as shown, the next thing is to draw an arc right up there like that. And once that is done, repeat the same procedure with point Q. So we have it as follows. And once that is done, put the pair of compasses aside. Next, you take a ruler and use it to draw a common tangent to the arcs that we had drawn, so that we get a result as that. So this line here is the locus of point R. So anywhere along this line we can have R, and the height here is constant throughout. So that is a constant distance from a fixed line PQ. So that is it for part A. Part B, if R is equidistant from P and Q, draw the locus of a point S such that PS is equal to 3.5 centimeters. So here we've been told that R is equidistant from P and Q. So that means we consider this R right up here, that one there, so that the distance between R and P, R and Q is the same. So if that is the consideration, the next part of the question, draw the locus of a point S such that PS is 3.5 centimeters. So here we should be able to identify that this is a constant radius locus, so that we have a radius distance from a fixed point P to the locus of point S. That is, if we center ourselves at point P, then the circle would be as that. So if you draw a circle round P, so the circumference right there will be the locus of point S, so that the distance from P to a point S on this circumference is 3.5 centimeters. So the next task here is to draw that locus in this diagram here. And first of all, we were told that R is equidistant from point P and Q. So let us locate R by bisecting line PQ. So we'll drop a perpendicular bisector that will definitely have to pass through point L, because point L is the midpoint. So we proceed as follows. Place the end of this compass at point P. Once that is done, next we'll have to put an arc right up there. And then at point Q, again we'll have to come and put an arc right up there. So we have it right up like that. And then once that is done, we can now drop the perpendicular line to PQ, and we expect it to pass through point L. So you place your ruler so that you are able to drop the perpendicular line that passes through the points of intersection of the arcs we had drawn earlier on, and of course it has to pass through point L, which is the midpoint. So once that is done, next we are going to get the locus of point S. So the locus of point S is the circle right up there. So we are going to position ourselves at point P, place the pair of compasses at point P, and measure the radius So we're going to have the radius 3.5. So we measure 3.5 right up there, 3.5. Once we've measured 3.5, next thing is to draw the locus. So the locus will be something like this. So once that is done, I think we can now move to part C. And before we move to part C, I hope we remember that this point here is R. We have point R at that particular point. So for part C, shade the region enclosed by the locus of RS and line RL. Remember, L was at this particular point. It's covered by the line. Inside triangle PQR, such that PS is greater than or equal to 3.5. So PS is this distance from P up to the locus of S. So this is the locus of S. So the distance from P to this circle is the PS. So we are told that we should shade the region enclosed by the locus of RS and line RL inside triangle PQR such that PS is greater than or equal to 3.5. So greater than or equal to 3.5, that would mean a distance beyond the radius. So first of all, we will have to get the triangle PQR that was stated earlier on. So we have PQR as that. So that is PR. We also have PQ, or rather RQ. And then from there we can begin shading. So the region beyond 3.5 centimeters inside the triangle will be given by this part. So on this other side, we have it less than 3.5 centimeters. So we shade the wanted region. So we want this other region, and it must also be in triangle PQR. So that's why I've shaded here. Remember, I'm not interested in this part because it's outside the triangle. Next, we're told that PR is less than or equal to RQ. So PR, like we have PR and RQ. And remember, R was a point on the locus. So here we are talking about this perpendicular bisector locus, perpendicular bisector of PQ. So if PR has to be less than or equal to RQ, then the side that is less than RQ is this other side. If it is greater than RQ, then we have to shade this other side towards RQ. But if it is less than or equal to PR, then it means we are moving towards PR. So we shade this direction of the locus. So finally, we've ended up shading the region that is required inside the triangle. Well, that's it for this question. I hope you've gained something. See you next time.